true. So generally when you're actually setting up your is less than value, it's a good idea to actually start with large values, make sure your particle flow is working well, and when you're happy with the overall flow, slowly reduce that value until you actually get more accurate results. And at some point there's going to be a point of diminishing returns where as you set that value lower and lower, more and more particles never actually test true. And it's probably at that point obviously you want to stop and use a value a little bit higher than that. Obviously you want it to be as low as possible because you want it to be accurate, but you don't want it to be too low because it'll be so accurate that the particles will actually never get within that range, and therefore you'll never get the result that you're looking for. Okay, so that's it for the control area of this test. And you know, as I said earlier, this is a kind of hybrid test in a way because it actually modifies the path of our particles. It's not just a test. And next what we want to do is actually move on to the next area of this test where we actually do a test and we actually look at the particles and we define things like what the target of the particle is and so forth. So let's actually do that now. The first option we have in this area is, do we actually collide with an icon or do we collide with a mesh object? And this radio button set allows you to choose between using the mesh, which you can see in this the mesh selection, which you can see in this list below, or you can actually use the gizmo provided by the Find Target test itself. So you've got the option of using one or the other there. Simply choose whichever option you need. If you select the mesh option, then you can use the selection list below to define exactly which meshes will be used as targets. The next option you have is a sync by flyout, which you can see here, and this is the usual flyout with, again, the usual options. You've got event duration, particle age, and absolute time. So again, absolute time is based on the timeline, the absolute timeline value. Particle age is based on the particular age of that particular particle that's been tested. Or you've got the event duration, which is obviously an offset to the particle age based on the time that it's actually been in that event. So on the first frame that a particle enters an event, it's effectively got an age of 0 within that event as far as the event is concerned. And you can then use this value to sync up any animation using those options. Generally particle age is the one that is the most useful, but it just really depends on the situation that you're working within. The next option is animated shape, which you can see here, and whilst this is active, this tick box will make the shape definitions of your geometry update per integration step for each of your target meshes, if any are actually defined at all, that is, of course. Of course, this will slow down your evaluation greatly, so it's best left disabled unless you really need it. You only need this option on deforming meshes, any meshes that are animating. As an example, a character would be a good example. If it's got a deforming mesh, which it's almost certainly going to have with skin or maybe physique, then you're going to have this option turned on. As I said, if the mesh of the target is not deforming, do not actually have this option on because it'll slow down the evaluation quite a bit. In a similar way, the follow target option will update the translation of your targets per integration step. Again, this will cause a bit of a slowdown, so again, only use this where your target's position changes. This is generally not such a heavy thing to work out because in that case you're only actually working at the change in the position of the target rather than an actual complete change in the surface mesh for target. So it's actually not as heavy as the animated shape option. The next thing we have to choose is a point. And this flyout is actually crucial in this respect, as it defines that point in space that the particle will actually steer towards. This and the following object flyout are logically out of order in the GUI, as in reality you first must define which object will be your target, and then you define the point on its surface. So I don't know why it was actually arranged this way in the user interface, but to me it's actually backwards. But anyway, let's have a look at what these options actually do. And as I've said, they are out of order. I'll actually explain them out of order because maybe it'll actually make a little bit more sense then. So let's have a look at what the object flyout actually gives us the choice of. We have a number of options here, as you can see, and we'll actually run from the top to the bottom, which will give us a good idea of actually what's going on here. We've got the random option, and with this option the operator will simply pick one of the listed meshes at random for each particle as it enters the event. So you can see we've got all these meshes picked here, which are these geospheres of here, and as